Students, in this session we are going to see about various graphs that represents the motion of the body. The first we are going to see about position time graphs. So this graph represents time in x-axis and position in y-axis. So the position means the distance or displacement. So the graph, the smooth line is a graph. So what is this represents? At time t is equal to 0, the position of the body is x0, that is x0. It may be a 1 centimeter or 1 meter or whatever it is. It is not at origin. The body starts its motion not in the origin, it starts from the certain position. So when the time increases, the body motion also increases. That is, the position of the body is also increases uniformly. So it is not a curve, zigzag curve, it is a smooth straight line curve. So it represents the motion of the body is uniform. Hence we can say that this graph represents object in uniform motion. So the position time graph, the position of the body equally changes with equal interval of time. Hence we say that it is a uniform motion. So in this graph, if you calculate the slope of the curve, so what is slope? The slope means tan theta. So tan theta means opposite side by adjacent. So here it is a theta. So opposite is QR and adjacent is PR. So QR represents x2 minus x1. Sir, how sir it is? So very clearly you can see that the point Q represents the position x2 in position axis and R represents position x1 in y axis. So the x2 minus x1 is the gap, the interval QR. Similarly, the PR represents the time interval t2 minus t1. So R as t2 and P in t1. So very clear, slope means y by x, that is opposite side by adjacent side. So in this curve, the opposite side represents x2 minus x1 and adjacent side represent t2 minus t1. So it is clearly, this is a change in, that is a displacement of the body. Final position and the initial position, the distance between the final and the initial position is called as a displacement. So the displacement by time interval. What is the displacement by time interval? Yes, it is a velocity. Hence, the slope of this time position time graph represents the velocity of the object. So this graph is a uniform motion. So we are able to calculate the velocity of the body by using this curve, simply calculating the position, simply calculating the slope of the curve. So slope is equal to velocity of the object. Next we see that the same curve, instead of position, if you put the velocity, that means velocity of the body is increases uniformly. So this is a velocity time graph of the uniformly accelerated motion. The body motion in uniform acceleration. So at the time t is equal to 0, the velocity of the body is V0, that means initial velocity. As the time increases at equal interval of time, the velocity also increases at equal interval. Hence this motion is a uniformly accelerated motion. If you take the slope of this curve, the slope means this Q represents the final velocity V2 and R represents the initial velocity V1 at this time interval T1 and T2. So what is the slope? Y by x, it is a V2 minus V1 by T2 minus T1. So there is a change in velocity, final velocity minus initial velocity. So the change in velocity by time interval is clearly gives it is a acceleration. So the acceleration of the body is defined as change in velocity by time interval. Very simply, the rate of change of velocity. Hence, in velocity time graph, this slope represents acceleration. In position time graph, this slope represents velocity. So distance by time is a, or a displacement by time is a velocity. Velocity by time is a acceleration. By using this velocity time graph, it is easy to find the displacement of the object also. Very simply, if you calculate the area under the curve which represents in the velocity time graph. So it is the same graph is redrawn here. but this shaded portion represents the area under the curve. So if you calculate the area of this curve, that will represent the displacement of the object in velocity time graph. So the area under the velocity time graph represents the displacement. If you write distance means in this y-axis you have to put speed. So in speed time graph only distance able to calculate. In velocity time graph we are able to calculate displacement covered by the object. So the area under the curve is, it is a representation of triangle and rectangle. If you calculate the area of the triangle and rectangle just to add up to these two things, this value represents the displacement of the object. And also in 11th standard, these type of graphs are repeated in the problems always. So this area is, this shape is a trapezium shape. So what is the area of the trapezium? The area of the trapezium is half into OA. There is two parallel lines, smaller parallel line and bigger line. These two are parallel to each other. So OA plus BD. So the area of the trapezium is half into OA plus BD into height of the trapezium. What is the height of the trapezium? It is OD. So the parallel side, opposite side of the trapezium we have to add and multiply with the height of the trapezium. Then you multiply with the half. Half into that is the parallel lines we have to add and multiply with the height of the trapezium. So this formula you have to remember always for the problem solving purpose. So what we are learn now, very simple, the position time graph. It is a uniform motion graph of the position time graph. This slope represents the velocity and then velocity time graph. So this slope represents the acceleration of the body. Then this graph, area under the graph in the velocity time graph represents displacement. Even you can draw the graph between acceleration in the y-axis and time in the x-axis. So this is an acceleration time graph. So in acceleration time graph, if you calculate the area under this curve in the acceleration time graph, that will represent velocity. So in velocity time graph, the area under the curve represents a displacement, and acceleration time graph, area under the curve represents velocity, because velocity is a displacement by time. Displacement is a velocity into time. So this area is the length into breadth. So that is the area. So we are able to easily calculate the displacement of the object. So there are the different types of graphs available. So next video or in the next session we are going to see about analysis of motion from various graphs. So the distance time graph, displacement time graph, velocity time graph, speed time graph and acceleration time graph. So for writing the classwork purpose, I will show the pages very slowly. Just you note down this. How to put first position time graph, draw the graph uniformly, accelerated motion time position time graph, and you copy that slope. That slope represents the velocity of the object. Then you move to the velocity time graph. It is also a uniformly accelerated motion. The motion represents, that means the slope represents the acceleration of the body. For the same velocity time graph, if you calculate the area under the curve, that area represents the distance or displacement of the object covered in this motion. So this is the next page. And then this area is, the shape of the area is equal to area of the trapezium. So I already told that it is a sum of the two parallel lines and product of the height of the trapezium into half. So in the next video or the next session we are going to see that various graphs that represents the motion of the body.